I am Anil Kumar and I wish all my students get 90 plus. And it's problems like these which get them to that level. So here's a very interesting question. I'd like you to copy the question, try it yourself, and then look into my suggestions. What we're trying to do here is graph inverse for set of points. Set of points, kind of important. Given f of x equals to a set of a comma a square such that a belongs to set of integers where a is greater than or equal to minus 2 but less than or equal to 2. You need to graph the function and its inverse on the same axis, state, domain and range of inverse of this function. Now what is this function given to us? Now the function really is f of x equals to a comma a square. Now what does that mean? It means if x value is a, then y value is a square. That is the relation between x and y value. So we can write the relation as y equals to x squared. Do you understand that part? Where a is given as values between minus 2 and 2. That means the values which x can take here are like minus 2, minus 1, 0, 1 and 2. So this is interpretation of this. Do you understand now? So treat a as a variable, and when you put them in these brackets, they are coordinate points. Okay, so these are my coordinate points. Now for different values, what do we have? We have points. So if x is equals to minus 2, then y will be minus 2 square, which is 4. With the result, we get points like minus 2, 4, minus 1, 1, 0, 0, 1, 1, and 2, 4. These are points very familiar to you for x square, kind of parabola, right? But this is not connected since we are only dealing with set of integers. Do you understand? Let's plot them. So if you plot them, you get 0, 0 here, 1, 1, minus 1, plus 1, and 2, 4, and minus 2, 4. So these are the points which you really get. Now that is your function. So you could have written this as f of x equals to this function. Now the inverse for you will be flip these points. You get 4 minus 2. Within this is the set of points, right? So let me put set here. Kind of very important notation. 1 minus 1. 0, 0 invariant. It just doesn't change. Same is the case with 1, 1, right? This is invariant since x and y are same points here. Do you understand? So these are our points. And if we have to plot the inverse of the function on the same axis, what do we get? 4 and minus 2. 4 and minus 2 is this one, right? 1 minus 1. 1 and minus 1 is here. 0, 0 is right there, common between the two, invariant point. 1, 1 is also invariant. Do you see that? And 4 and 2. So these are the points which you get, and that is the function which we are talking about. So the inverse of the function is shown to you in this color, right? Now we can write domain range for inverse. So what is the domain range for inverse? Domain is all these numbers. Do you see that? So the domain is equals to 4, 1, 0, right? And you don't have to write 0, 4. You don't have to repeat them, correct? So that is what the domain is. And how about the range? Range is the y values, which are minus 2, minus 1, 0, 1, and 2. As you can see, domain and range flips. The domain given to us was between minus 2 and 2, including both. In the inverse, it flips. It becomes the range. Do you see that? And that is the solution of this problem. Have a good look at it. Try to understand what we did. And remember, if you have a question where we have variable belonging to not the real numbers, then you should not be connecting the points. It's kind of a scatter plot as shown here. I hope you appreciate it. Thank you and all the best.